Hey everyone, so this is chapter 3, number 27 in our night book. So it reads, a ball is thrown horizontally from a 20-meter high building with a speed of 5 meters per second. And part A asks us to make a sketch of the ball's trajectory. So the first thing we should do is, again, write down what we know. We know the building is going to be 20 meters high, and the ball gets thrown with a speed of 5 meters per second. Okay, so for part A, they say, again, draw a sketch of what's happening, what ball's trajectory. So here's our building, there's the ground, and when it gets thrown horizontally, and as it goes, it falls a little steeper and steeper the whole way through. So that is part B. I'm sorry, A. Part B now asks us to draw a graph of v sub x, the horizontal velocity, as a function of time. Make sure to label both axes. So we've got our two items here, our axes, where we've got v sub x, which is in meters per second, and we have the time, which is in seconds. Put our tick marks in, like that. All right, and because the speed is constant the whole time, every second, right, in projectile motion, it's going to make a nice straight constant line because we have a constant speed, so our graph should look something like this. Right, part C says, draw a graph of v sub y, the vertical velocity, as a function of time. Include units on both sides. Right, so we've got C here. We're going to make our graph. Right, so we have v sub y, which could be in meters per second. We have our time, which is in seconds. Make our marks again. And as we go here, we start at 0, 0, and as it falls, it gets faster and faster and faster. So we need to show that in our graph. So it starts at 0. Because it's falling in the negative direction, it's going to have a negative slope, and it should have a negative slope that is equal to negative 9.8, which again is gravity, which is causing it to move in that rate. So the last thing we've got is part D, which says, how far from the base of the building does the ball hit the ground? All right, so we want to know what is x. What is that x distance we have? The thing that's holding us back, and really the thing that we should always find first if we're not given it, is what is the time. We might have to find that. We don't have enough information in the x direction to actually solve for the time, so we need to go to y. So I'm going to go with y equals y sub o plus v sub o y t plus 1/2 g t squared. All right, when we do that, we know that y is 20. That's the height of our building. If we take the origin to be right at the base here, then our y sub o is going to be equal to 0. Right? V sub o y is equal to 0 because it gets shot completely horizontally, so there is no y component. So we'll make that a 0 there. And then we're left with 1/2 negative 9.8 and then t squared. Okay? We do the math, right? Come out with an answer that t should be equal to 2.02 seconds. Now that we're armed with that time, we can go and find that x. We go with x equals x sub o plus v sub o x t plus 1/2 a t squared. X is what we need to find. Again, if we take the base here to be the origin, then x sub o is going to be equal to 0. And because it is in the x direction, there is no acceleration. It stays at constant velocity the whole way through. We're left then with just v sub o x times t. And v sub o x is equal to v, so it's 5, and then times 2.02. So x is going to be equal to 10.1 meters. And that's it. That is number 27 for you.